Welcome, students. Today we're going to be building a game with Monogame and XNA. Just a very simple game as a way of getting us familiar with that framework and illustrating some of the things that we want to do with that. So if you jump to the Monogame web page, if you jump to the front page, you'll notice there is this Getting Started section over here in the sidebar. You can jump in, you can look for your particular operating system. All of our examples that we're going to be going over in this class will be on the Windows system. You can potentially run this in other platforms as well, but this is how all my videos will be based, and there are some differences as you move between those. And the recommendation is to run Monogame with Visual Studio 2022. That's what we have pre-installed in our labs, and this is what I would encourage you to also install for your own machines. And if you are a K-State CS student, then you can actually download the Enterprise Edition of Visual Studio 2022 for free. Otherwise, you may end up using the Community Edition, which should be free. And you need to make sure that at the bare minimum you have the .NET Desktop Development workflow installed. You can see when you go to the workflows, you can check these boxes. I'll show you how to do that here in just a minute. Once you have Visual Studio installed, you can double check. If you want to do mobile development, you'll need the mobile development workflow marked as well. And if you want to target the Universal Windows platform, that one will need to be checked as well. And once you have that, you need to install the Monogame project templates. And this gives us everything else that we need to actually do Monogame. So real quickly, the Tools menu, you can go to Get Tools and Features. And this will show you the Visual Studio installer, and it will, in a moment, show us those different workloads that you can check. So this is where that particular dialog was coming from. You just check which ones you need, and you go ahead and click the Install button, and that will install that. And for the extensions, those are from the Extensions menu. So you can go into Manage Extensions, and you can go to the Visual Studio Marketplace and search for Monogame, and it will be the first one that pops up, and you can click on that and install it if you don't have it yet. And you can see I've already installed it. I have the little green check mark there saying that that is part of my platform. And what that does for us is it gives us several templates. So if we go to New Project, we can actually look at, even search for Monogame. You'll see that there's several different possible starter projects that we can run with for a desktop application using or a cross-platform desktop application. So this one should run with Windows, Linux, and Mac OS. I don't want to use OpenGL. Then there's one that uses DirectX, and it will only run on Windows using traditional desktop development and also the universal Windows development. So you can kind of pick and choose from the detail or the level that we're going to be working at Monogame with. These are going to basically look the same. We're not going to see the difference, but I'm going to go ahead and use the DirectX version because that's actually kind of closest to the original version of XNA. XNA was specifically for Windows and for the Xbox 360 and for the Windows Phone, which you may have never even heard of, but it really was entirely Microsoft products. And then when Monogame took over, they started looking more at cross-platform. And then I'm going to go ahead and call this Hello Game. And I'm going to change where this is going. I'm going to put this in 580 folder. And you can, of course, put these wherever makes sense for you and your file organization. So this gives me a starter project, which is a Monogame game. I'm going to walk you through a little bit of the code. So our entry point is, of course, program, which you may have seen this before. The newest version of C# allows us to do the scripting style. So this used to be declared as a class and had a static method called main, and notice none of that is here. Now we just say that we're using this hellogame.game, so this game class out of the hellogame namespace, and then we're calling its run method. So that gets us this class, and this is really the lion's share of what we work with in Monogame. So here we have our game class that was created for us from the template. And you'll notice that there is a bit of logic already in here. We already have two members in our class, a graphics device manager and a sprite batch. Talk about those in just a moment. You'll also notice the game inherits from a base game class, which is part of the XNA framework. And that provides a lot of the hooks into how whatever our operating system is, in this case Windows, and how to manage some of that detail. Now you'll also notice that we have three methods, the constructor, the initialize, and the load content, which have to do with initialization, getting the game up and running. Each one of those operates in a very specific way. First we construct the class. Immediately after it's constructed, its initialization gets called, and after that initialization gets called, load content gets called. So those happen in order. You might be wondering, why do we have three? Well, one of the big distinctions between load content and initialize is initialize happens before we have a reference to the graphics card. So before we've actually set up our connection with that graphics device. And the load content is after that. So anything we need to do that manipulates or especially puts anything into video memory, that needs to happen in the load content. We don't want to do that before that because we don't actually have a reference to the graphics card. We'll actually end up crashing the program if we try. The initialize is good for setting up any part of your game, and the nice thing about it is you could recall this to restart the game if you wanted to go back to an initial state. Say you did something like a Pac-Man game, whereas the constructor is basically all the system level initialization that we need to do that really only needs to be done once. So that's kind of the way to think about those three. And then we have the two parts of our game loop. We have this update method, which just updates the game world, updates the logic of the game, and this draw method, which then draws the game. And these two we just iterate over in basically an infinite loop. We call update, then we call draw, update, draw, update, draw, update, draw. And if we go ahead and run this game, you'll see that we just get a window with a nice cornflower blue background and the hello game there. And that's really it for right now. Okay, let's go ahead and make this into something a little more interesting. We're going to add a ball to the screen and just have it bounce around in the area available to it. So in order to do this, we need to basically have a texture for a ball that we're going to use. And that's going to be added to our content folder here. I'm going to go ahead and just add a new item. Actually, I'll find it in my downloads and I will pull it across and drop it in there. And just double check that that's actually shows what we have. We have a ball with a transparent background. That's what we want. And then I'm going to open this content project, content.mgcb. This should open the MGCB editor. That's Monogame Content Builder Editor. This is basically a GUI for working with a command line tool, which is a content builder, which takes content like an image, in this case a PNG image, and transforms it into binary data that can be used by the game. And this is actually a very customizable process. We'll look at the content pipeline a little later in the semester. But for now, any kind of external asset file that you're working with probably is going to be imported through this editor, and that really gets it into a format that's game ready, quick to load, minimizes the amount of extra data that actually comes with that. So we want to practice working with that. And I'm going to add existing item here, and I'm going to grab that ball that I added to the content folder, and notice by default it looks in the content folder first. And you want to make sure that that stuff is in your content folder when you build your project, and especially when you submit to GitHub, because otherwise that won't be coming with your source file. So it really needs to be in that folder. Now up at the top here there is the build you can run or rebuild. You don't actually have to, you just need to save your changes, and the reason I say you don't have to is part of the actual build process of Visual Studio, because we've installed the extensions. And if you look in the dependencies here, you'll notice that of the NuGet packages, it has this content builder task. That task is going to trigger and actually do the build process for us as well. So there's no need to build it in the builder, but you can, and if you do, it will tell you any errors that actually occurred, and it's sometimes easier to debug those here than it is in Visual Studio. And you can see there it said, oh, I was able to build that. So in order to bring this ball into our game, we're going to need a texture variable, which is a texture 2D. And I'm going to go ahead and call this ball texture. And I'm also going to create a vector 2 for the position of the ball. So now if I come down into my initialize function, and again, we have these different places where we can do initialization. Because the position of the ball doesn't depend on the graphics card at all to start with, we would actually set that here. So ball position equals a new vector 2. And let's say we want to put it at the middle of the screen. Well, how do we know where the middle of the screen is? The graphics device, which is accessible through our graphics device manager, which is _graphics, has a reference to the viewport we're using. And that viewport has a width, which is how big the screen actually is in pixels. We can divide that by 2, and that gets us halfway across the screen. And we do the same thing for the height. And that should be roughly halfway across the screen. And then when we come down to our load content, because the texture we want in video memory, we don't want to load it until the graphics device has been initialized, which happens between the initialize function and the load content function calls. So here we'd say texture, ball texture, equals, and then to load that binary content that's created by the content pipeline when it processes that ball image, we have to use the content manager. So content.load is the function we want to use. You'll notice this is a templated function. We have to tell it what kind of object we're actually loading. So in our case, a texture 2D. And then we supply the name of that content. And that's the same as the file name, except without the extension. Because what actually happens when we build this is it will create a new file using the same file name called ball, which is actually a binary file which contains the raw data that we actually want to use in a format that can be loaded. And that's why we have to specify this as a texture 2D. That tells the content loader how to interpret that binary data to turn it back into a texture that we can actually use. If we use the wrong thing there, it's going to end up with gibberish. So we're not going to do anything in the update yet, but we are going to draw. So down here you notice that our first command is graphicsdevice.clear. That clears our back buffer to a solid color. And then we do any of our drawing code, and then we call base.draw. And that base.draw is going to update, draw everything out, take that back buffer and flip it with the front buffer so that becomes what's displayed on screen. And in a video game, we actually have 2 buffers, or potentially more than that, but we never actually draw directly into what's being displayed on the screen. We draw to an off-screen buffer, and we swap them. That way we don't have partially drawn stuff popping in as we're playing our game. We want to see a completed scene, followed by a completed scene, followed by a completed scene, followed by a completed scene. These need to move fast enough that we can actually create the illusion of motion. So that's actually one of the big challenges of video game programming, is we have to do all of this very quickly. And how quickly? Usually 1/30th or 1/60th of a second to actually update the game world and then update the scene so that we can create that illusion of motion. So this is where that sprite batch that we saw at the very top comes in. So the sprite batch is a tool for helping us draw 2D stuff in a 3D world, because DirectX or OpenGL, depending on which version of Monogame project you're using, are actually rendering in 3D. They're rendering a 3D world, but we're actually working in 2D. The sprite batch provides us a simplified way of handling, drawing 2D elements within that 3D world. And it has the name batch because what it's actually doing is batching up a whole bunch of drawing calls and then executing them all at once. So we need a sprite batch.begin and a sprite batch.end to start that batching process, and to say the batching process is done, go ahead and draw everything. And then in between is where we actually put our drawing commands. So in this case, sprite batch.draw. And we're just going to use the simplest version of this. You notice there are 7 overrides. There's a lot of different variations on how we can do this. The very simplest one just takes a texture, which we're going to use our ball texture. It takes either a rectangle for where you want to draw it on the screen, or a vector 2, which is the second override, and that's the one we're going to use, which is ball position. And then the third is a color. We're going to use white. So this is a color that's going to be blended with that sprite. So white just says keep all the original colors the same. If we use something like red, that would make it actually have a red tint to it, or we could do blue or green or something like that. So you can use that to flash, for example, when you hit a wall or something like that, if you want to do anything more fancy. So now if we were to run this, we should see our ball, and it should appear pretty much in the center of the screen. And there it is. And you notice I said pretty much, it's not actually centered, but if you were to actually draw out the bounding box of this ball, the edges of the ball, and turn it into a box, you notice the center of the screen is about where that mouse cursor is right now, or the upper left-hand corner. And this is an important thing to understand about screen coordinates, is typically when we're drawing something in screen coordinates, especially a texture, we're actually looking at the origin being the upper left-hand corner of that image, for that image's coordinate space. So basically we start drawing at that upper left-hand corner and draw out to the right and down. So in order to make this actually behave the way we want it to, if we wanted to actually really have it centered, we need to subtract from this position half of the width and the height of the image. In this case, this is a 64 pixel wide image. I can just go ahead and subtract 64 from the width and 64 from the height. And that gets divided by 2. So that should end up centering us, or I could subtract 32 after I divide. And now you can see our ball is actually centered. Okay, so the next part, how do we actually move that ball around the screen? Well, let's add another vector 2 to be our ball velocity. So this one, we're going to pick a random velocity. And in order to use a random number, you probably know that it comes from system. There is a random number generator in the system namespace that we can use. Actually, rather than using system, I don't really want to pull in that whole thing. Let's just come down here and in our initialize, because I really only need to use it in initialize, let's create a system.random. And this is going to create a new random number generator for us to use. And we're going to set our ball velocity to be a new vector 2 with that random, with a random double value. So this is a number between 0 and 1, and 0 and 1. And notice that it is actually a little upset with us there. It wants this to actually be a float. So we have to cast that double to a float. And the reason we do that, or why we have to actually do the cast, is because a float has less precision than a double. So we're actually getting a less precise, i.e. less decimal places are actually represented in that number. And the vector 2 is uses floats internally, not doubles. And this is part of XNA was built to run on Windows and Windows Mobile and the Xbox 360, and they use these smaller precision floats instead of doubles throughout the framework, which made it easier to run across all those different platforms. So that's just something that we continue in Monogame, even though most of our modern systems are 64-bit. We're still using 32-bit floating point numbers. Okay, so that gets us the velocity, a random velocity. And but that is going to be basically a number between 0 and 1. We want to add that velocity to our sprite to basically move our sprite. So we can come down to our update function and say the ball position and just add to it with the plus equals operator the ball velocity. This is one of the really cool things about XNA is that it uses a lot of the overrides, so we can actually override and just say we want to do vector addition here, and it just understands what that means and will apply vector addition. So it's going to add the X components together and the Y components together and then apply that back to the ball position. So ball position is going to be updated to include a little boost from that ball velocity. Now, again, are thinking about it, this is not going to be a lot of change every frame. And remember this update, Monogame uses by default what we call a fixed frame rate. So it's actually going to call these methods, basically try to time it so that it takes just a fixed amount of time between each update. And that mimics the earliest kinds of game programming we did on things like the NES and the Atari, where we knew exactly how fast the system clock was. And so we would have basically the same operation would take the same amount of time across every NES. Modern computers have all kinds of clock rates, so it can vary quite a bit. So there's a little extra math hidden in the game subclass that we're working with that actually looks at especially our monitor refresh rate and tries to create or tries to keep our frames only being updated as frequently as our monitor refresh. That's the default. You can actually turn that off and say run as fast as you can, and you can get as many frames per second as you want. There's really no reason to go past your monitor refresh rate though, because it's only going to redraw at that rate. So you're basically doing extra work and throwing away frames that you didn't need to do. And those thrown away frames, that equates to a lot of lost power. And if you're working on a laptop, a lot of extra heat that you didn't need to actually generate. So generally speaking, we want to try to use the fixed frame rate, but that frame rate can vary. If it's a 30 frames per second monitor and a 30 millihertz refresh rate, then that's going to be a smaller number than if it's a 60 frames per second refresh rate. So we need to know what our monitor is and all that. That's taken care of for us. But what we can do here is we can actually scale this by whatever that rate is from this game time variable. It gets passed in. And the game time has a time span property, the elapsed game time, which is basically how much time has elapsed between this frame and the prior frame. And that's generally going to be the same as long as our game is running. It should be fairly steady. And that would be 1/30th of a second or 1/60th of a second, or it depends on our synchronization with our monitor. And we really want total seconds here. And that'll give us the amount in seconds as again, a double, so we'll actually have to scale that or cast that to be a float. So then we take this float times the ball velocity, and again, this is overridden, so this is actually going to multiply the x and the y of this vector by this value, and then that's going to get added to that ball position. So we're actually going to make it scale the vector and then update the position. Now, if we want to do the other kinds of multiplication that we can do with vectors, cross product or dot product, those are not part of any override because there's no extra multiplication symbols. We only have one. So for those, you have to do vector2 dot, for example, for the dot product, or you can do vector2 dot cross for the cross product. Well, maybe they don't do cross product, but they do the dot product. Multiply is basically the method that we're doing here. It's just we're using the operator override. So those are available in the library. They're just not conveniently mapped to a operator. Okay, so that updates our position. But again, now if we come back up and look at this, I said these were going to be between 0 and 1. Now we're multiplying by the total number of seconds, which is also going to be very fractional. This is going to be moving super slow because there's not a lot of pixels that are going to be moved each time. So what we probably want to do is go ahead and scale this up. But before I do that, I'm going to take this velocity and normalize it. So the normalize function is going to, and this is notice it has no return type. So what this actually does, this mutates the value of our vector, and it normalizes it, which just means it shortens it to length 1. So that accounts for, if we had two very large random numbers close to 1 time, and then two that were closer to 0 the next time, one would be a long vector, one would be a short vector. This makes sure no matter what random vector we end up with, it's just a direction of unit length. And then we want to scale that to give it kind of a sense of speed. We'll take that ball velocity again and multiply it by, in this case, I'm going to do 100. So basically, every time we hit that update method, we will take that velocity and apply it. So now it's length 100. So we're going to move 100 pixels each frame. Each time we hit, 100 pixels roughly per second, because we're scaling it by the number of seconds. So now if we run this, we should have our ball appearing on screen and moving, and eventually it will go off screen, and bye-bye. Okay. Now, that's not terribly exciting. Let's do a little bit more. Let's make sure that we don't go off the screen. So we can take that ball position and ask, is it off screen? So one of the easiest things we could check is if that ball position dot x less than 0, that means we're moving off the left-hand side of the screen. Or if it's greater than the right side of the screen. So how do we know what the right side of the screen is? Well, we have that graphics device. Viewport width, which tells us how wide the screen is. So we could say, okay, if it's bigger than that, then what we want to do is we want to flip our velocity in the x position. So we can take that ball position dot x and multiply that by -1. That will change that x, so now it's negative. It's going to change the sign, and actually it's not the position we want to change. It is the velocity. So the velocity is now in the opposite direction, which next frame means it will start moving back onto the screen. We can do a little extra logic if we want to kind of deal with when it gets partially off the screen and bring it back on. Depending on how fast our ball is moving, that's not going to be a big deal. If it's moving very fast, it can be a very big deal. In fact, if it's moving too fast, we end up with something we call the bullet through paper problem, where our ball can actually end up so far off screen when we reverse its direction, it doesn't make it back on screen, and because it's always to the left, it just kind of does this back and forth there. Now, with the speed of 100, that's not going to be an issue for us, but it could be otherwise. Now, the other thing we might think about is that because our ball is 64 pixels and we're drawing it from the upper left-hand corner, this will actually let the ball get all the way off the screen before it starts coming back. If we subtract the width of the ball, that means only the right edge of the ball is going to touch the edge of the screen before it comes back. And then finally, there is a chance that the viewport is not actually has its left at 0, in which case we could actually say viewport dot x instead of 0 here, and we won't go past the left side of the viewport. So that gives us that that makes sure that we're actually looking at where the viewport is rather than necessarily just a hard-coded value. So that will keep us on screen to the left and right. And let's go ahead and you probably shouldn't copy paste, we know better, but there are times it's very easy and useful. So we're just going to do that for the viewport y and just change all of these x's to y's and the width to a height. And make sure that we're changing the y component of our velocity. Now if we run this, our ball should bounce off the sides. And what did I miss? Color. Ah. I don't know how we got system.drawing in there, but we don't want system.drawing. Notice that what it was talking about an ambiguity between system.drawing.color and xna.color, because they both define a color class. So that's one of the reasons we want to avoid pulling in all of the system libraries, because XNA redefines several terms, and then we have to really worry about our namespaces as we're doing that. So that's why I did system.graphics rather as a fully quantified name rather than using the using statement. So now we can bounce our ball around, and we see a nice behavior. And this gives you the basis for animating sprite moving around the screen in the game. This is really covers all the core concepts you need to get started. So hopefully this went well. If you have any trouble setting up Monogame or the MCGB editor, double check the documentation. If you still have trouble, let me know, and we'll take a look at it together. So congratulations on building your first Monogame game.